This unpredictability is the holy grail of modern cybersecurity. True randomness. Humans have long tried to extract high-quality randomness from nature. But it's tough, requiring a balance between speed, cost, and stability. Software-based randomness often shows patterns, failing to protect. That's why security must begin with true randomness from nature. Only it can resist AI, quantum, and brute force attacks. In 2015, E-Memory found randomness in silicon. By leveraging tiny manufacturing variations and oxide defects, we triggered quantum tunneling to create unique, irreproducible fingerprints, a natural-like source of randomness. NeoPup creates true randomness and chip-unique fingerprints. It prevents counterfeit access, generates endless encryption keys, and resists brute force attacks. With NeoPup, E-Memory is building future security. From root of trust, crypto coprocessor to PQC, it's the cornerstone of embedded security. NeoPup secures IoT, automotive, AI, blockchain, aerospace, and defense. It protects networks and devices, building trust across all electronics. NeoPup, born and mass-produced in Taiwan, now expands globally. Next, it enters Intel's 18-nm process to protect the US from the chip level upward. NeoPup, as the holy grail of security, transforms unpredictable chaos into a trusted core within chips, protecting our interconnected world from the silicon level upward.
Please welcome Chairman with E-Memory Technology, Dr. Charles Hsu.
Hi, good morning, everyone. I'm here to share with you exciting technology, NeoPUF, which is the holy grail of the securities. And there are 4 parts in my presentations. First, I will talk about the chip securities, and then I will talk about the NeoPUF-based root of trust. And then I will report the security IPs on Intel 18.8. And finally is a summary of my presentations. So for chiplet security, it requires hardware root of trust to perform following security functions like supply chain traceability and secure boot and authentication and signature encryption and also secure communications. So I like to point out the best hardware root of trust is the NeoPuF based root of trust. NeoPuF base of root of trust consists of NeoPuF, which create unique ID and also root keys, and also it also includes the NeoPUF OTP, which for the secure storage, and it also includes the NeoPuF-based TRNG, and which can speed up the random number generations. Because the NeoPuF is a very important technology for the security, so I like to talk about the mechanism of it. By applying, because we use the random number extraction but from the comparison of tunneling currents. So we apply the voltage into a pair of MOS device, and the tunneling current will be occur, which could be in the left-hand side or on the right-hand side. But each side, the tunneling current will have the 50% of possibilities. So if the current on the left-hand side, we label it as 1, and on the right-hand side, we label it as 0. And we can design 256 pair, and we can get the 256 bit of the puff, and which can create 2 to 206 random number. And we also use the Hamming way and also Hamming distance and also bit error rate. evaluate the quality of our PUF. And from this slides, it shows that we conclude that our NeoPuF has our NeoPuF has the ideal PUF, and which has a very high entropy and also the reliabilities. And next, I'm going to talk about how to use a NeoPuF to protect the secret key. So here it shows that the secret key is injected into 2 chips. Then each chip has its own PUF numbers, and this PUF number can scramble the secure keys and become the different numbers and all stored in the different locations. And this is how NeoPuF protect the secure keys. And I also like to explain how PUF can facilitate the true random number generations. As on the top is the traditional true random number generation, which use the 4 noise source and go through the post-processing and create the random numbers. But the speed is too slow. But if we can incorporate NeoPuF with the 4 different noise source, then go through the entropy refined energies engine, and we can create the random number very fast. So the speed is by this NeoPuF incorporate random number generation is about 100 times than the traditional random number generations. So based on the NeoPuF technology, we are able to develop many security IP, which from the root of trust, and also become the security coprocessors, which we add the crypto and also the PQC, and to become the secure processors by adding the CPUs. And by using this IP to be in the Intel's 18.8, we can support the customers' need on those security IPs. And this IP can also be employed in the chip securities and to perform the functions which I mentioned earlier. And E-Memory has joined Intel's chiplet alliance and to accelerate our innovation on the chip securities. And in summary, the zero trust security is needed now, and the NeoPuF, which is chip fingerprint, and which can create the unique identity and also create the root keys, and they protect the secret keys, and also facilitate high-speed true random number generations and enable zero trust securities. And with this NeoPuF technologies, we are able to support Intel 18.8 and to become the very high performance and also not only high performance but also very secure process node. And this concludes my presentation. Thank you.